tried to test those. So when we saw these results, we had some hypotheses. Barefoot kicks result in a low accuracy as compared to all shoe conditions, again. So our guess was maybe the bony prominences of the foot create pressure peaks, causing a less homogeneous pressure distribution between foot and ball. And so that the upper material of the leather actually sort of smoothes out the bony prominences. But of course, one of the hypotheses that we had, ball sensing or touch of the ball, seems to play a minor role in kicking because the accuracy was worst in the, let's say, most touch condition, the barefoot condition. So then the shoes, what was the difference between the shoes? The Nike Air Legend showed significantly better accuracy, as been seen here. But coming back to a question, it was not something that really companies would go for. They would rather use an oblique lacing to have a smooth surface on that side where they actually touch the ball. So the Nike Air Legend actually has the seams in the middle, whereas all the others have some covers or have oblique lacing to provide a smooth surface on the part where the foot makes contact with the ball. So that was not really the secret. So the next step for our research was how to prove the shape factor hypothesis. And so we looked into measuring the pressure between the ball and the shoe. We had 20 male soccer players in 2 shoe models. We asked them to do 200 side kicks and 200 inner step kicks. And this is the experimental setup. We used pedar measuring insole, but not as an insole, but on top of the shoe. We prepared the shoes to hold the pressure pad in place. And we only used 35 from 99 active sensors just because we had to have a high frequency to detect the pressures. The sampling frequency with the 35 active sensors could be 570 hertz, and we know the contact time is only about 10 milliseconds, so we couldn't really go with a higher resolution for our pressure pad. Just skip through the attachment of the measuring pad very quickly. So we have an initial fastening, then we have sort of a stretch rubber around, and then we anchor it at the studs. And we wanted to know, well, how does the upper compare where the sole is with the foot anatomy? And we were considering to do MRI, but that would be very expensive and very difficult for 20 subjects with 5 shoe conditions. So we actually chose another way. We had the subject sitting there with a shoe on. We pushed one of the sensors, seeing it on the screen here, and the subject had to identify on the skeleton where they felt where the pressure is. So kicking on the target was done the following way. So we attached the electronics to the pressure pad, and then this is the target, and the subject is kicking on the target. So let's look at the results for, in this case, the total 90. So for the side kick, this is the pressure values from all the subjects doing the side kicks. And you see the center of pressure in red here. And you see for the inner step kick another location, probably a little further more to the lateral side there. So first of all, there is an anterior lateral shift of the center of pressure against the side kicking technique. So we have all those values, and we have sort of the peak pressure picture, that really the highest pictures that have occurred throughout the contact, and we did an analysis on this one. So if we compare the Air Legend, it was a better shoe against the total 90. We have this difference in the first study, and if we repeat the study, we have not significant, but a similar trend. But of course, we have modified the upper. So it is not really the actual shoe as it has been. So even with the modified shoe conditions, change in shoe upper properties by the additional sensor array, there's a trend for the Nike Air Legend to provide a better kicking accuracy against the Total 90. So the shape factor hypothesis, the more even the pressure distribution, the better the kicking accuracy. Lower pressure differences between adjacent transducers should then mean a more even pressure distribution. And so to estimate the smoothness, we did a sum of delta analysis. Following way, we actually just calculated the difference between adjacent transducers, summed all of them up, and then did our calculations. So when we do that for the 20 subjects, for the Air Legend, we have a delta sum for, in this case, the side kick of 800, for the Total 90 of 980. So there is a more even distributed pressure for the Air Legend. We do it for the instep kicks. We have an even greater difference, 795 against 943. And you might see that there is this big green patch, meaning equal pressure, and there's more variation here, and that explains the difference. Conclusion. For the side and the inner step kicks, the Air Legend has a more uniform pressure distribution pattern during contact of the ball with the shoe, and therefore the shape factor is likely to be one among other reasons for the better kicking accuracy of the Air Legend. Okay, we could also look at the spin production because we had the pressure distribution data, and we can conclude from the rotation of the ball during the contact with the foot. So roll distance is an indirect measure of spin production, as shown by previous tennis ball studies. And so for all successful kicks from our subjects within the target area, a regression analysis was performed, roll distance versus kicking accuracy. And as you can see, there is no correlation between those. So we can reject that hypothesis. So there's no dependency between roll distance and kicking accuracy, and therefore subjects appear not to use ball spin to achieve a more stable path of flight. Then we looked at the surface structure on kicking accuracy, meaning if there is a sticky surface, is that one of the quality criterions to have a better precision? We had 18 soccer players for best accuracy again, using an inside or instep kicking techniques on their choice. And as an alternative, use a full instep kicking technique. And we had, besides the Nike shoe, we had two Nomis shoes that are very sticky upper, and Nomis dry and Nomis wet. And we also modified one shoe by different shrouds that provide different coefficients of friction between the ball and the shoe. So this would be the attachment of the covers. If we look at the conditions, this is the Nomis shoe and the Nomis wet shoe, very sticky surfaces. This is the accuracy again, and you see they don't really make a big difference in terms of their property of the upper. We have the Total 90 in this case being the best one without the shrouds, and we have small values differences here. But if you look more closely, and we do not find a correlation between the coefficient of friction and precision, so we measured the coefficients of friction technically and compared them to the results, but there was no correlation found. But if you look very closely, the surface structure of the shrouds had an influence. For a smoother surface structure, accuracy increases. So these were fairly rough structures, less accuracy. This is a fairly hard rubber. This is a fairly soft rubber material, and so the soft rubber material could smoothen out some uneven pressures, so it appears that it goes through the same directions that we had before. For the fall-in step, similar picture. The rougher the surface, the less the accuracy, and this is a smooth surface, and we have better accuracy there. So uneven surface structures result in lower accuracy. Summary, the surface structure is the main factor for influencing accuracy. Rough and uneven surface structures resulted for both kicking techniques in reduced precision, and smooth surfaces probably generate a more even distribution of pressures between the shoe and the ball. To follow the ideas of previous studies, an experiment was designed to reduce pressure peaks caused by the bony prominences of the foot, and that could be either modify the shoe or more easily padding of the foot. So we are actually looking for a special shoe and look, well, where does it really fill, where the bony prominences, can we smoothen them out individually for a person?